presentations on all kinds of astronomical topics. Things are starting to get a little excited. It's been a very, very busy morning. Deborah and I had a meeting with the captain less than an hour ago. I'll tell you about that beginning at 2 o'clock, so don't leave after this talk. Our speaker today is Mike Reynolds, Dr. Mike, who's Dean of Natural Sciences at Florida
State College versus unnatural sciences.
Natural sciences, as opposed to the unnatural sciences.
That's right.
And Mike has assured me that everyone who stays through his entire talk and awake will be given a free half-pound meteorite at the end. Is that
Courtesy
right?
of Sky and Telescope magazine.
Oh, I see. Okay. Anyway, you know that he's an expert on many subjects, and his passion is collecting and talking about meteorites. So please, a round of applause for Dr. Mike Reynolds.
Thank you, Kelly. Thank you, everyone, for being here. I know it's hard to release our focus on eclipses at a time like this. I'm thinking to myself, I gotta give a talk on meteorites, and I'm so eclipse oriented. I get this kind of an eclipse funk that some of you may have noticed today, where I'm just so eclipse oriented and thinking through what has to happen, and my mind does not necessarily wander to one of my favorite topics in my research areas, that's meteoritics. But it'll give us a little bit of a mind break, and I'm a good lead band for the main treat, and that's Kelly talking about the eclipse. So at least give you a chance to catch a few Z's after lunch, relax, that sort of thing. It's amazing what can change someone's life. I got interested in space as a kid, first grade. I remember my teacher rolled in a TV set and said, today, America is going to launch the first astronaut, a guy by the name of Alan Shepard. And as a 7-year-old, I was just enthralled. My parents had no interest in science, no interest in astronomy or space, whatever. They didn't know where this weird kid came from, but I continued to get more and more interested in astronomy and space exploration. And probably partially a product of that space exploration golden age of the 1960s. But I remember when I was in 3rd grade, our class, about 1963, took a trip to the Children's Museum. And my mom gave me my 25 or 50 cents milk money. And we went to the gift shop, and they had little small pieces of Canon Diablo meteorite. You buy it for like 25 or 50 cents. My mom was so mad that her 9-year-old had spent his milk money on a piece of iron from space that, I just never heard the end of it. But I still have that little piece of iron from space, and it's turned into be quite a passion. So today we're going to very quickly, this is going to move fast, and so as I've tried to do in the past, I have most of you've already got, I think Cheryl and Debbie were handing out a reprint from this summer's astronomy magazine, an article I wrote about collecting meteorites. And so it's a very, very nice handout. And I do have some extras I'll put back at the Travel Quest tables. I do not want to haul in my suitcase back home. So anyway, there's a nice handout so you do not have to take notes for this afternoon's test. But you think about meteoritics, and part of it is explain to people the difference between meteoroid, meteor, and meteorite. And you think about some of the great opportunities to see meteor showers or meteor storms. This is a very well-known etching that's at the American Museum of the 1833 Leonid storm. Now imagine not knowing a lot about space and literally see the sky falling, seeing the solar storm. People thought the end of the world was near. I guess I was just very lucky as a kid, because my first meteor shower was the 1966 Leonids. Now those of you know about the 66 Leonids, it was a storm. Where I was at in Florida, we only got a measly 10,000 an hour. We didn't get the 100,000 an hour that got out west. But here I am, 10, 11, I thought, oh, meteor showers produce 10,000 an hour. It's like my first comet was Ikea-Seki, 1965, this great sun grazer comet. And so I got kind of spoiled as a kid with these things. And we've had some opportunities to see some nice Leonid storms or really strong bursts. This is about a 3-minute exposure I took out in California, Northern California. And in this one frame of about 3 minutes exposure, There's 50 meteors and of course your obligatory plane going through the field of view. But it's absolutely incredible. I just remember thinking of them as being like a waterfall, these meteors falling from the sky. A good friend of mine who's since passed away, that many of you knew, Vic Winter, took this gorgeous image from the outback, and this is a little bit of Photoshop. He obviously photoshopped in Ayers Rock, but look at this. This is just spectacular. And then you can easily see the radiant going back into a point. Now these of course are not, should I say, the source of our meteorites that we're going to spend most of the time talking about, though some people think they are. Here we got Foxtrot. He's outside holding up his catcher's mitt trying to catch a meteor. These meteor showers are always such a letdown, and good morning to you too. So, you know, this is not the source of our meteorites, but I did want to just talk a little bit about meteors. You know, basically we look at our comets that leave material as they go around the sun, like little breadcrumbs, and Earth will run into these breadcrumbs seasonally, depending on which particular comet it is, and we see these wonderful meteor showers, sometimes much more spectacular, sometimes a little bit disappointing, but nonetheless, it can be quite a treat. So let's jump on in and let's talk about meteorites. So I'm going to warn you, even though I am a college dean, even though I'm a PhD, you know, piled higher and deeper PhD, there's going to be some humor in this. So you're going to have to, you know, just humor me as I take you through the story of meteorites. So first question is, how do you know if it's a meteorite or not? Well, see, how much you think I'm going to use all sorts of science? I go to Madame Ruby, the soothsayer, the tarot reader, the card reader, and she tells me if it's a meteorite or not. Now this is actually a funny story. I saw this sign, I said, I've got to have a picture of this for my presentation. So I pull up, get out, you know, trot up with my camera, take a picture of Madame Ruby's sign. I'm telling you the truth here, out comes Madame Ruby. I think, oh God, what am I going to say now? So Madame Ruby asked me, you know, what are you doing? I'm thinking, well, you're Madame Ruby, you tell me what I'm doing. What are you asking me this? So I told her how beautiful her sign was, I was going to make it world famous and things like that. So anyway, Madame Ruby and her meteorite identification usually is not the best way. What we do first, when we're in the field or someone brings something that I think is a suspect meteorite, is we look for 3 or 4 identification clues. Do they attract a magnet? Most, 99% roughly, of meteorites have some iron in them. If it's a fresh fall, has been sitting on the desert floor or Antarctica, the Antarctic meteorites can be very fresh because of the way they're preserved. Do they have what's known as a fusion crust, like a melted layer? Do they have some sort of shaping which indicates they've come through the atmosphere? And probably the cool thing is they have these little thumbprints called regmaglyphs. By the way, I know Kelly, and I really enjoyed it, Kelly, your 3D presentation yesterday. I'm also doing a 3D presentation, but it won't be today. When we do our little meteorite luncheon in a few days, I actually brought meteorites with me. But I knew it would be difficult today, again, with the passion, with the eclipse and that sort of thing. But I brought some sample iron, stony irons. I brought a Martian meteorite and a lunar meteorite. And you've got to enjoy these because do you know what it's like trying to take meteorites through security? You just assume the position because you know what's coming. They're all kind of gathering around the X-ray machine, you know, looking to see whose this is. And I'm smiling while all the terrorists are going by, you know. Here goes my meteorites to the machine. But I usually use it as a chance to lecture and kind of get people interested, which is always kind of fun. It doesn't always work out. So just a real quick kind of preview. Again, most meteorites attract a magnet, and you've got to have the right type of magnet, by the way. I know it's a little fuzzy. This is an eclipse magnet. Now, is that appropriate? So there's a little bit early eclipse astronomy there. And we'll talk about the names and the classifications. I can really get into a lot of detail here, but I will not. And those of you who would like to talk about more meteoritic chemistry and you know, that sort of thing, be glad to do that at our little luncheon we'll have in a few days. So Gibeon is an iron meteorite, and in my lab at college, what I do is I do a chemical test for nickel. Nickel and iron are found in combination in these meteorites, and there's no earth iron that has this sort of nickel in it. So I do a qualitative test for nickel, and basically it's pretty straightforward. It's like the pregnancy test for meteorites. Basically you use a little bit of acid to loosen up a little bit of the iron-nickel combination, a little bit of base to neutralize that, the dimethyl glyoxome, which in the presence of nickel pops pink like it's pregnant. And I think you can see the pink? These are meteorite samples. If they don't turn pink, they're not. So either it's pregnant or it's not. And it's a good test for me to take in the field when I do my travel and recovering meteorites or go to a crater, because I think these little, like, eye dropper bottles full of what looks like eyedropper stuff, I'm actually taking these chemicals with me, in my checked luggage, and it's a good way for me to test in the field. Fusion crust. This is a meteorite called Ben Sauer, and it was a very fresh fall. Notice the black crusting on this, which indicates flight through the atmosphere. Beautiful interior whitish gray matrix, but a wonderful darkish, almost charcoalish like exterior fusion crust. Aerodynamic shaping, we'll talk more about silicaga, which some of you know why that one's particularly famous. But the shaping a meteorite seems to end up with, as it comes to the atmosphere, as it orients itself. We actually studied meteorites, in particular one type of tektite called an australite, to shape the blunt end of our spacecraft. And so those indications, how things oriented and came through the atmosphere, allowed us to do some spacecraft heat shield shaping. I'd like to have brought this one. This is a wonderful sample. This is from Canyon Diablo in Arizona. However, it looks like a weapon. It looks like, like an axe type of weapon. It's been very definitely kind of hammered down at the one end, but beautiful regmaglyphs, these thumbprints, these digs that happen as it comes to the atmosphere or due to the explosive forces of impact. So can you find a meteorite? It's shows like Meteorite Men on TV, the popularity of meteorite collecting. I'm asked this question all the time. I get an opportunity about once a month to travel somewhere around the globe and give a lecture on meteorites and a book signing. So I'm always asked, people always bring me stuff, which we'll talk about stuff in a moment. So can you actually find one? Here's an amazing statistic. The total mass of meteorites in everything, museums, universities, colleges, private collections, is less than the annual production of meteorites. Are fairly rare. In fact, there was an article in Newsweek, about 10, 15 years ago, that said the new Beanie Babies, which may not be a good thing to identify with meteorites because they are such a collectible. Again, you get some ideas. A lot of this stuff does rain down on the Earth, but becomes atmospheric dust, lands in the ocean, just never recovered. So most of this, if you live in a place like I live, like Debbie and I live in Florida, there's not a lot of meteorites that have been recovered from Florida. But if you live in a place like Kansas, there's been more meteorites recovered from Kansas. So, how? I like this. It's acting a little slow, but that's okay. How are meteorites classified? Well, basically we do it by composition. Iron meteorites, which are mostly iron. Stony meteorites, which are mostly stony. Again, we can get more into the chemistry, those of you who are interested in stony irons. And then I threw in Dr. Mike's fourth classification, meteorongs. Get it? Meteor, right? Meteor. Okay. If you don't, I'll explain it to you later. It's amazing how many meteorongs I get. Being a college dean, a college professor, someone who's written books and articles about meteorites, people send me stuff. And I think one time out of all this stuff, someone actually sent me a meteorite. Probably the coolest thing I ever got, a fellow who was a soldier in Iraq sent me this that he found in the desert. It turns out something called a fulgurite. A fulgurite is where lightning has hit the soil and caused the soil to fuse. So if you haven't got a meteorite, but you got a really cool thing. I get a lot of slag and a lot of just junk. My favorite though, honest to goodness, box comes, I open it up, and it is a dried cow patty. It's life on other planets. I'm glad I was the first to be able to see this. And people quite often get very upset when you say, this is not a meteorite. They think you're trying to rip them off because they've seen some of the prices, especially some of these Martian and lunar meteorites. They think you're trying to rip them off. So how do you name meteorites? The names are fantastic. The names are based on the closest post office, usually. You have some differentiation when you come to Antarctic meteorites, like ALH 84001, Allen Hills, 1984, the first meteorite they picked up. Then you end up with the Northwest African NWAs, which are basically recovered somewhere in the Sahara Desert region. But you got these great names of meteorites that are based basically on the city. There are some historic names, and we'll talk about some of those historic names, but it's just a small sample of the thousands of meteorite names that there are out there. Just really fantastic names themselves. It has nothing to do with, you know, the asteroid they possibly came from, or, you know, the type of meteorites, where they fell. So iron meteorites, you think that iron's the biggest group. It's not. The stone meteorites are, but people identify so much with iron meteorites. Iron's obviously the predominant metal. You have nickel between 5 and 50%. And again, that allows me to go back and do that DMG test to see if there's nickel within the meteorite. Trace of cobalt, some other, you know, sprinkling of this, a little bit of that, but those are the predominant metals, and you base them on the ratio of iron to nickel. The hexahedrites, the octahedrites, and the ataxites. Again, those of you interested in the chemistry, we can have hours worth of conversation on this. It's fun stuff. I want to show you a bunch of pictures, but I have some real ones to show you for those of you who are interested a little bit later on. This is called box hole, and again, it's a nice chunk of iron. You see a big indentation here, a little bit of that oxide that Kelly talked about when we talked about Mars. Again, lots and lots of pictures I can show you. To me, the best way to learn about meteorites is look at pictures, number one, but look at the real things, number two. Odessa, Texas, it's called a coarse octahedrite. Again, nice chunk of iron. By the way, it's funny because if someone was to break into our home and got past our dogs, they would see these hunks of iron laying around and think, what type of bozo collects hunks of iron? Not easily realizing they're going past thousands of dollars in, you know, iron meteorites. You know, and they're great doorstops, by the way. No, I did not find this one like this. This is Gibeon from Namibia, and there was so much of this being recovered about 15, 20 years ago. They were making knives and cue balls and jewelry and all sorts of really cool things from it. So this is a cue ball that's been machined from a full Gibeon meteorite. But the reason I like this, besides it's kind of way cool, is that when you etch a octahedrite, you have nickel and iron. They form a crystalline pattern, an octahedral pattern. As you etch them with acid, the iron and nickel eat at different rates or dissolve at different rates, and you end up with this wonderful line pattern that's called the Widman-Staten pattern. It's kind of funny because you know, I love my wife dearly, and she harasses me. I won't say, she's been very kind with me about my purchasing of meteorites. And when I bought this is about 15 years ago. I think I paid like $100 for it. He said, Mike, are you crazy about a $100 cue ball? Today that cue ball would cost you about $750. So the question now is, why don't we buy more of these cue balls? They're worth more than our stock is. So some people do collect meteorites as an investment. I'm more the researcher type, educator, as you know. This is maybe one of my favorites because this thing looks like a meteorite. This is a Russian fall. And when this thing came in 1947, the folks who lived near the Sokote-Lin mountains heard a huge explosion, and shrapnel came in and covered the hillside. These things look like meteorites. Now, those of you who collect meteorites, you probably have one of these. Hold on to it. This one's starting to dry up. There's less and less of these coming out of Russia because, you know, these things are not endless, as we found out, like with Gibeon, for example. Maybe one of my favorite meteorites, because of my past work with Chabot Space and Science Center, is Goose Lake. There was an alert given to the Smithsonian in 1936 that a big meteorite had been found by hunters at the California-Oregon border. So an expedition was assembled through the director of the Chabot Observatory, and they went up and carted this meteorite out. And so, you know, I spent 12 years as a director of Chabot, from 1991 to 2003. So I always had a passion for this particular meteorite. And here I am with the Goose Lake thinking now, okay, can I like put this in my carry-on luggage and haul it away? You think they let me get away with that? But this is one of the big iron masses you will see at the Smithsonian today. It's a wonderful meteorite. An interesting story. We think, because looking at the chemistry of this is actually probably a throwout from Canyon Diablo, Arizona. Imagine that impact. It would not have been a fun day, or it could have been a fun day if you're underneath it. Stone or stony meteorites. Well, these are your major group of meteorites. 94% of meteorites found today are stone or stony meteorites. Crust and mantle of asteroids, maybe some cometary material, lunar and Martian meteorites. I have samples of Martian and lunar meteorites with me. If you've never touched Mars, I mean, this is kind of way cool. I think about my students I teach. We do a lab on meteorites and think, oh, this is going to be boring. Reynolds will bring out a bunch of rocks, and by the end of it, they're just loving it. So then, especially when Mars is visible through the scope, they look at Mars through the telescope, and then they touch Mars. What a cool thing. Even though an 18-year-old won't tell you they think it's cool, you can tell they think it's cool. So anyway, we also look at other things within these stony meteorites. Most of them contain little blobs of iron and nickel. I've got some samples of that also. We base them on chondrules, which we call them chondrites or achondrites. You can get into chemistry here, but because of time, and some of you would be throwing stuff at me if I start talking about a lot of chemistry, really great, cool stuff I just want to talk about, but Kelly also wants to talk about this thing. This is Eclipse I think we have tomorrow, so we'll get back to that a little later on. So let me just show you some samples again. This is a really fairly fresh fall that fell in China called Wanqing. Beautiful meteorite, has this dark fusion crust again, and this beautiful kind of almost a purplish grayish internal matrix. Meteorites can kind of look ugly, but then you start getting into them and slicing them and looking at the interior and understanding where these things came from. That's when it's like, man, that's pretty cool stuff. This is Johnson City. Again, the one side and then the slice. I'm probably the only weirdo in Jacksonville, Northeast Florida, and in my garage I have iron cutting saws. I cut iron meteorites, which takes a long time, stone meteorites, stony irons. I use oil-fed saws, and don't tell anybody, please, but I also make meteorite jewelry. But don't tell anybody, PhDs aren't supposed to do stuff like that. We're not supposed to make jewelry, so don't your secret is safe, I hope. So anyway, beautiful, beautiful meteorites. Cutting them again, I use special saws. Most of these are done not by hand as I'm showing here, but most of them are done with an automatic device that moves them through oil cutting. It will take, usually it takes about, for a stone meteorite, about 20 minutes to cut an inch. Use a special diamond blade and again, special oil to lubricate the saw as it's cutting, and then I'll do some shaping and such as that depending on what I'm trying to go for. This is a wonderful Australian meteorite, very, very rare. It's called achondrite, what we call eucrite. And again, we can talk more about asteroids and such as that, and those of you who join me for lunch. And I know I'm kind of pushing for time here, and so I'm watching my watches. I know we're all anticipating this thing called an eclipse, and when I get the updates from Kelly and such as that. Stony irons. Now, nature is just spectacular. And you think about the stony iron meteorites. This is a combination of silicates, which of course your stony meteorites, and your iron nickel in about the same proportion. So this is like, can you imagine a collision between two asteroids and this material becoming mixed together? About 1%, so a very small percentage of all meteorites are stony irons. And we have two major groups. They've been kind of going back and forth, but we have what's known as the pallasites, which to me, this group right here, this is celestial art. I think it's all celestial art, but this right here is spectacular. And the mesositerites, which I think are unfairly called the garbage can meteorites, but they're actually pretty cool looking too. But the pallasites, by far, are the most spectacular. And the best way to study the pallasites are the interior. So this is a pallasite called Imelak. It's found in Chile in the Atacama. And so what I do is I had a big chunk that I had gotten from a friend who collected it for me. And we'll all of us work together and we'll exchange meteorites and meteorite samples. So I have this chunk of Imelak, and it actually is kind of yucky looking from the outside. It's one of my favorite sayings of my grandson, Michael, yucky. So it's kind of yucky looking on the outside. If you take it and you slice it, very thin slices, and you end up with this absolutely spectacular iron nickel. See that? You can see the kind of silvery looking, and these embedded olivine, ladies, peridot crystals found within the iron nickel matrix. Just unbelievable. It's one of the wonderful times that my wife said we were looking at 2 samples at a Tucson show, which is, by the way, one of the best places to go look at meteorites if you're interested in buying. We'll talk a little bit about that too. But a fellow was showing us 2 slices, and I said, well, which one should we get? And Debbie said, both. So gentlemen, there's your clue. This is a piece of Imelak, again, lit from the back. I have a piece of this with me. And you hold it up to light, you can see this beautiful olivine, greenish olivine within the iron nickel matrix. It is absolutely spectacular. Now, not all of the pallasites are created equal. Some, unfortunately, have been more weathered, more oxidized. And when you get some of those samples, they are kind of crumbly, and pieces can fall off. And if you cut them improperly, what I do is when I cut, I'll cut one side, polish it, and then coat it with something called Opticon, very thin material that that gemologists use, and gives me that protection, helps hold the olivine in place, and then cut the thin slices on the other side. But this stuff, it's just spectacular, and it's gotten very expensive. When we talk about buying meteorites, it's going to sound like a bad drug deal. You start talking about buying it per gram price. Unfortunately, Imelak is somewhere in the neighborhood of $35 to $50 a gram. It is very expensive because it's become very rare. There are others that are spectacular. You just, again, it's going to sound funny, I'll talk about this one. You know your dealer. That sounds kind of strange, doesn't it? Know your dealer. So Imelak, a spectacular type of pallasite. This is Vaca Muerta. Okay, those of you who speak Spanish, dead cow. This is the dead cow meteorite. So you're thinking, okay, why do you call it dead cow? Well, where this was discovered, by the way, this is a mesosiderite. I think I brought this particular sample with me. This was found along a cattle path, and there are cattle bones, so they just called it the cow killer, even though it probably didn't kill any cows. It makes a great story, though, doesn't it? It's not a post office box in this particular case, but the dead cow meteorites. And I have kids look at it and say, oh yeah, that looks like a little pig to me. There's the eye of the pig, there's the ear, and so it's like seeing shapes in clouds. Interesting and rare meteorites. Oh, again, I could spend an hour talking about just this stuff, because part of this gets back to Kelly's talk yesterday. These are Martian meteorites. This is part of the Smithsonian collection. When I was at Chabot, I had an opportunity to work with Smithsonian and the Smithsonian meteoriticists, and this is part of their collection of Martian meteorites. We classify Martians in 3 basic groups, so there are some subgroups now. The Shergottites, the Knocklites, and the Chazagnites. And you're looking at some of the bigger pieces that are, of these particular specific specimens, though we just recently had a fall of Martian meteorites turning out to be a very large fall of Martian meteorites. So you're looking at, if you were to buy these 3 samples, and they're not that big, we're not talking about boulders here, we're talking about thumb-sized samples, probably $1 million. Very, very, very rare. And again, when we work with all these things within the Smithsonian, you wear the white gloves and you're protecting the meteorites and that sort of thing, because oils on your hands can do nasty, naughty things to meteorites. So, I have my students, feel and lick and taste and smell and stuff like that. Then I have my samples that they get electrocuted if they come near us. So, kind of building again. Kelly's excellent talk about Mars yesterday. He asked the question: meteorites from Mars. How do we know these are from Mars? There's like a little stamp on the back that says "Made on Mars." How do we know these things are actually from Mars? Well, there are clues that as good detectives we follow, as good scientists we follow. First of all, if you look at we call them SNCs. You might remember again, just stepping back real quick, back. SNCs, Shergottites, Knocklites, and Chaziknites, so we call them the SNCs. So there are certain clues as a good astro detective, astrogeologist we follow. First of all, these rocks appear to have had the same parent planet, not Earth, not the moon. So they have that same sort of characteristic. Remember Kelly talking yesterday about the basalts. These are igneous with basaltic type of composition, but the major clue is doing some really good chemistry. There's these particular elements called the noble gases, argon, krypton, xenon, and neon in particular, that are found within the SNCs at levels that are similar to the Viking spacecraft data. Kelly was talking yesterday about the fact that when we landed these two Vikings on Mars in 1976, they did really great chemistry. And they really were looking for life, and they were doing all sorts of sniffing and really good chemical work. Well, they did a lot of research on not just the percentages, but the isotopes of argon, krypton, xenon, and neon, and argon in particular. And so, several years later, in the early 1980s, someone was studying some meteorites from Antarctica, and they said, "Oh my gosh, where have I seen this data before? This particular isotope and percentage of argon." They dug back in the literature, and guess what? It's the same data as Martian Viking landers. And so it's like a thumbprint. It says, "I'm from Mars, I'm from Mars, I'm from Mars." And so we can easily go in and determine these rocks are from Mars. So how do you get them off of Mars? Well, you have to have something that hits Mars. Again, Kelly, it's like I listened to what you said yesterday. You have something that hits Mars, blows Martian pieces out in space, they circle, 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 and eventually you're looking up and you get clobbered by one. So it's a fun bit of detective work that we do in the meteorite business. This is a more recent fall found in Northwest Africa. Again, this is another Shergottite. You can see how fractured it is from impact. And by the way, sometimes you'll see I include these are called the standard cube. This is 1 centimeter by 1 centimeter. Actually, it's 1 centimeter by 1 centimeter by 1 centimeter, just so you get a feel for the sizes we're talking about here. Some of us very fortunate to be on Aram's first expedition to Antarctica. I know that Nina Widdens here, myself, there's about 7 or 8 of us were there with Aram when we went to Antarctica, and I got to go along as the meteorite guy. And I'm going to tell you, it was a wonderful trip. I would not trade it for anything. If you ever get a chance to go, but it is not for the faint of heart. You do not have room service. You can get on your TV and say, "Bring me a pot of coffee, please." We went in the middle of the Antarctic summer, where it was a nice balmy 30 below zero. You get there, the things that struck me about Antarctica was white, just everywhere white. You don't see any life except for its crazy humans once you get inland. And again, this is a whole nother talk in itself. But again, talk to Nina, talk to myself. It was and Aram will be here, talk to Aram about it. He's had a couple of expeditions since then. Aram and I were tent mates for our 3 weeks in Antarctica. And here's our home and our window view. So those of you, as you look out your porthole, you see the beauty of the Pacific. Think about looking out your porthole with your plastic chair and seeing the beauty of Antarctica. It was spectacular, absolutely spectacular. The conditions could be deadly. You had these katabatic winds that would come over the mountains, and literally you took your life in your own hands. You had to be very, very careful. You had to think about what you were going to do, whether it be get up and go to the mess tent or the little boys, little girls room, which I will show you an example of. See, you didn't know you were going to talk about potty training in here, did you? So anyway, the winds were really something. Speaking of the potty, when we went out to search for meteorites, we had several little trips around Antarctica. You're out in the middle of nowhere, and so you basically you could use a pee bottle is a nice way to put it, but sometimes you need to do other things. So we had an ice toilet, and here obviously is the ice toilet. So several questions immediately come to mind. Now, see, you didn't realize you come to a lecture on meteorites and hear about using the bathroom in Antarctica, did you? But no pun intended. But the good news is, even though it's extremely cold, you would sit down, and your rear would kind of warm the seat, so you'd be warm for a bit. You just did not sit there and read the newspaper. Plus, Antarctica, there are certain rules. Ram and I had a ton of paperwork to fill out that went back to National Science Foundation, and it included you've got to bring in your own supplies, including your own aviation fuel, and you've got to take out all waste. All waste. Should I repeat that? All waste. So we're flying home, and I know, like I know we'll say also, we're all glad to get on that Aeroflot and take off and head back to Chile. Sitting next to me is a 35-gallon drum filled with. And I'm thinking, okay, if this plane crashes and I'm killed by a frozen drum of poo, that's what's going to be on my tombstone. But it was a great experience. And of course, we went out and we looked for rocks. We made a little side trip to the South Pole Station, and we all had our pictures taken by the South Pole. That is the South Pole. And unless you've been to Antarctica like mine, and I've been to Antarctica, and Ron, when he gets on board, we've done something none of you have ever done. We've run all the way around the Earth. Seems to go around the pole, okay, I bet you never thought I would run around the Earth, but I'm looking very studly there. As I take off my 3 wraps, my 5 gloves to have my picture taken, look at the flag. But again, just a fantastic experience. It was funny, is they had a little gift shop, and the gift shop mostly has stickers and things like that, but they also have liquor. And the rule was, unless you live here, you cannot buy the liquor. It's saved to people who live in Antarctica, and I said, yeah, I can understand why. But we did get a chance to go out and look for meteorites, and we would basically comb the rocks, and this is the way meteorite searching is done in Antarctica. You would go along the, I say rocks, along the glaciation, the glacier near a Nanatuck or near a mountain, and that's where the glacier runs into it, pushes the meteorites up. They've been kind of conveyor belted along, and so you would go along and you would look for rocks. Basically, we would walk along and look for different samples. And great picture of Bill Whidden inspecting and trying to keep from drooling on a meteorite. I love this particular picture, and again, GPSing it, and again, the opportunity to observe it. By the way, when you remove or collect meteorites from Antarctica, you do not keep them, which is a good thing. Because what happens, they go back to the Lunar Receiving Laboratory at the Johnson Space Center, and then they're distributed back out for people to research. So, you take them, you pack them, you send them back, and then they're redistributed back out. Speaking of Martian meteorites, some of you will recognize this name instantly. This is Allen Hill's ALH 84001. This was the infamous, or maybe now not so famous, Martian meteorite that was originally announced as having fossilized bacteria. And so many of us are really excited about this, and so far the jury has kind of leaned definitely back, I won't say definitely, but back the other direction, where it probably was not fossilized bacteria. It was geologic inclusion. It seemed to be a little bit too large, but I got a chance to do some research with this. I'm at the Smithsonian, and this is an actual petrograph, a photophotography shot I took of one of the inclusions of within the ALH 84001, and they looked at these, and the initial thought was they look like fossilized bacterium. And as they've gone back and studied, they found geologic structures that look very similar, and these turn out to be probably too big to be a fossilized bacterium. And someone's going to ask me, how big is it? And I don't remember. I had to go back and I'd Google it if I could, but we know how that works here, so we'll check it out and let you know. You know, here's the problem. You folks are like me. You read the wrong stuff. We read Sky and Telescope, and we read astronomy, and Smithsonian, and Scientific American, and you know, if you're a AAS member like I mean, you read various journals. We're reading the wrong stuff. So you need to be reading Weekly World News. That's where you get your real, here it is, NASA rover discovers Eskimo tribe on Mars. And here you see, here you got the little tribe here in it. Like, see the little probe, isn't that cute? And look, by the way, Dr. Atkins, be proud, low carb miracle. They live to 140 on all blubber diet.
Is that 140 Martian years or Earth years?
Exactly. Oh, I love it. 140 Martian or Earth years. That's so anyway, see, we're all reading the wrong stuff. I'll say more about Weekly World News in a little bit, but I love these. I have fun in my astronomy classes showing them stuff like this, then watching some of their reactions like, well, Reynolds, isn't that true? It's in Weekly World News. Come on now. It's like everything on the internet's true, isn't it true? Back to doing some research. This is an Antarctic lunar meteorite we were working with at the Smithsonian. It kind of reminded me, as you see from the picture, like a piece of concrete. But again, as we study moon rocks and then compare lunar meteorites, which I do have a slice of a lunar meteorite for you to look at, with Apollo and the Russian samples brought back the Luna samples. It's interesting. We do have folks like Mike Farmer who've gone over and they look for recovering meteorites in a variety of places in the world. This is one that Mike found that was kind of shaped like a horn or off a velociraptor. It would kind of remind me of a claw. You can see it here. Isn't that a wild shape? So several of us have little small slices of this particular meteorite. Look how dark it is. And we talk about how dark the moon really is. I mean, this is just a fantastic sample that was recovered about 7 years ago by Mike Farmer. Maybe one of the most unusual and wonderful meteorites is the Tucson ring. Again, if you get to the Smithsonian, there's a lot of museums around the world that have wonderful meteorite collections for you to look at. If you get to the Smithsonian, the Museum of Natural History, make sure you take in the meteorite gallery. I think it's actually called the Hooker Hall of Gems and Minerals, and it's nicely done. They just did a terrific job on it. And you'll see next to the Hope Diamond, the Tucson ring. This is a big iron meteorite. Big, I mean, we're talking about big iron meteorite. And this is the way it was recovered. For many years, this was used as an anvil because it, made of iron, being perfect thing for those in Tucson to hammer their iron onto. Now it's in the Smithsonian. Just, I mean, imagine again this thing coming to the atmosphere and then burning this hole where you have a complete ring. This is a fairly rare sample, should I say, with a hole like that. Meteorites with holes are not very common. Big ones like this are very, very, very rare. All right, I'm watching my watch here as I know we're all waiting for Kelly. Do a little bit of Eclipse stuff here. Chicken Little, the sky is falling. Well, yeah, it kind of is doing just that. I love this card. You got the big dinosaur and little graduating dinosaurs. The typical graduation message. And remember, graduation is not an ending, but a beginning. And here comes in the big Chicxulub incident that's going to cremate all these poor little dinosaurs. So I love that graduation card. It's just so spectacular. Here's another one. It's the real reason for geochemical anomalies at the KT boundary, which of course what we look at to talk about the end of the dinosaurs and the possibility of a big impactor. And here you have, the big war-making dinosaur pointing to his bomb saying, "Fellow dinosaurs, let me present to you the most technologically advanced and powerful weapon ever devised by our kind, the iridium bomb." So there you go, the dinosaurs blasted themselves into oblivion with the iridium bomb. But yes, we know Earth and solar system objects have been impacted and impacted. There's evidence everywhere you look throughout the solar system, or you have a solid body you can look at, whether you're looking at our own Earth, the moon, you look at the terrestrial planets, you look at moons of other worlds, asteroids, comets. We see impacts, evidence everywhere. And so we know that the solar system has been, and continues to be, a very violent place, including here on Earth. This is a mailbox that got hit by a meteorite about the size of my fist, called Claxon, Georgia. Now that's definitely a special delivery. You might add there, it's kind of interesting. Some of you might recall the great fireball that happened in the Northeast during a Friday night, 1993, I'm trying to remember, sorry, just space cadetted it out, that everybody saw like a Friday night football game, nice video and still photography, and this meteorite came through this car, this Malibu Classic car trunk, and landed on the ground. Here's the meteorite. Again, give you some idea of the size, about melon size. And in fact, look at the meteorite, look at the red paint in the car. By the way, the owner of the car also sold the car. You're seated? $50,000. I was thinking, maybe I just take a meteorite out, hammer on my car, and put it on eBay and say, I can buy a meteorite, and I'll take whatever you want to bid on it, of course. We'll talk about that again. All right, so a little bit more humor. I warned you about humor, and it says here that no one has been known to have been struck by a falling meteorite, although a dog was killed in Egypt by a meteorite years ago. Poor Snoopy. What do they mean? Although a dog. And actually that's maybe just a wives' tale. This is the Nakla fall, and actually someone has been hit by a meteorite. And some of you may recall having read or having seen about Sylacauga, Alabama, 1954. Mrs. Hodges was relaxing on her couch when through her roof came an orange-sized meteorite, struck a wall radial and hit her in the hip and arm and left this kind of nasty bruise. It's kind of a sad story, again, which we had enough time to talk about in detail, but I will add this one comment. She lived across the street from the Comet Drive-In Theater. That's Twilight Zone right there. Here we go. Again, you're not reading the right stuff. Weekly World News. Here, another meteor. They need a meteorite. Another meteor fells the Pope. So they're picking on the poor Pope here, and here you have he's a lava rock is pushing the Pope. I just love it. Jeez. Debbie and I would go to the store, and of course she'd go to do her shopping. And I was looking for Weekly World News, and I remember buying one of these wonderful astronomical things. And the woman at the counter said, "Sir, do you read this stuff?" I said, "Well, I'm a college professor," and I bring it. "Sure, that'll be $2.75. Thank you, sir. Whatever you say." So these are great. I call that a Popenite, by the way. I had a chance to do a lot of research in craters. Again, I kind of watch them. I'll watch here. We'll go quickly. Odessa, Texas. Obviously, the wonderful Barringer crater, where you're talking about something that's about 4,100 feet across, that was created by a rock about the size of this theater. It's amazing if you think about it. Had a chance to do some research in a crater called the Swang crater in South Africa. Originally thought to be volcanic and was determined to be meteoritic. We looked for all sorts of evidence of meteorite impact on melt glasses. In particular, we looked for things called shatter cones. Maybe one of the biggest shatter cones I've ever seen is this one, held by a friend of mine by the name of Mark Bostic. This is evidence where you have this incredible force of impact which shatters rocks into these incredible shapes, and called a shatter cone. This is from Beaverhead, Montana. Collecting meteorites, we're running towards the end here. As again, I know we're tight on time. People ask me about collecting meteorites all the time, and I do have some suggestions if you are a new meteorite collector. Read, 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 read. Look at other people's collections. Go to museums. Get in touch with people and take a look what they've got. It sounds weird, I know. Find a good dealer, like, dude, find a good dealer. Start off with smaller pieces, because some meteorites can be very, very expensive, but start off with smaller pieces, what we call a micro or gem jar collection. Again, this little reprint has all that in it. Be careful what you buy, though. Be careful. There are very good folks who sell meteorites on eBay. There are others who, well, I'll let you just look at this. This was, honest to goodness, this is a real Andes on eBay. A huge meteorite from Mars, positive identification by a vision. And notice the starting bid is $7 million. You can see how many bids. There's no bids on it, but again, just and they do, by the way, accept PayPal if you're interested. So anyway, again, just be cautious and talk to people. I've got my business card. You can always email me or give me a call. Talking Meteorites, so you can do that. Micro collections. There are people who do sell little micro collections of meteorites and get you kind of started looking at samples. This happens to be one of the Chilean collections. Those of you who are really into jewelry, this is a Rolex. That the face of the Rolex is an iron meteorite. It's been etched to show the Vidman-Staten pattern, of course, with beautiful diamonds, and it's only $42,500. So we'll let you add that to your collection. Be careful again what you read. Everything you see is not, you know that. This was an interesting photograph that was taken a few years ago in 2004. This fellow thought he'd actually photographed an impact. Since then, the feeling is it was some sort of anomaly in the photographic device itself, and he really did not try to fake this, but there are different stories. It is not an impact. So more information about meteorites. I'm wrapping up here. Kelly, turn over to you. All sorts of wonderful books, the Nininger books, especially Find a Falling Star. Again, I wish I had time to talk about this in more detail. Great books to read. Dick Norton's books on rocks from space and the books he's written are absolutely fantastic. Meteorite magazine, you can keep up to date on new falls and finds. Some guy by the name of Reynolds wrote a couple books on meteorites. I'm kind of pleased it's actually gone into a second edition, which means that it's actually selling a few books. It's kind of fun. You can find it in museum bookstores and Smithsonian and through SpaceWeather, spaceweather.com. You can buy it. And this is fine. Okay, I'm finishing it. But wait, there's more. I've written other books too, so you don't already know that. So operators are saying, we can't because nothing works here. So I'm going to host a luncheon in a couple of days. We'll put it up on a chart, very similar to what Steve O'Meara did. We'll do a luncheon on meteorites for those you want to come talk about more meteorite stuff. And we'll do at high noon on the 15th, the day after Eclipse, in the Ocean View Cafe. And I invite you to join me then. So I know I'm out of time, and I know we're going to talk about something more fun than meteorites. We're going to talk about eclipses. And with that, I'm going to turn it over to Deborah. Am I turning over to Deborah or turning over to Kelly? Over to Deborah. All right. So thank you very much, and keep looking up. And by the way, I do, again, if you didn't get a handout on the meteorites, I'll put some of the Travel Quest table, and I do have a few more of the handouts on photography that we distributed the other day. So with that, I'm going to sign off and say, I guess I said Bula to begin with, should I? So thank you very much.
Thank you very much, Mike. That was wonderful. Can everybody give another hand for Mike Reynolds? Well, here we are.